Today we'll be working on the following problem 6. Let E be a Lebesgue measurable subset of R with a Lebesgue measure mu of E greater than 0. And then we define this difference of E itself, E minus E, namely x minus y. Both x and y are in E. Now show that there exists a delta greater than 0 such that E minus E, this difference set, contains the open interval from minus delta to delta. Okay, so pause the video if you want to work on this problem by yourself. There is a hint, like we use the result from last problem, problem 5. Okay, let's prove this. So basically, we want to find a delta greater than 0, such that for all x sub 0 in this open interval, there exists x and y in E, such that x sub 0 is x minus y, right? That's our goal. So that is to say, like, if we define this set E shifted by x sub 0, and then we intersect E is not empty, because in such case we have some y, right? So our goal is to find delta so that these two sets overlaps. Now recall what we proved in problem 5. For all lambda between 0 and y, there exists a open interval a and b from a to b such that the measure of the intersection of E and this interval is greater than a lambda times the measure of this open interval, which is b minus a, right? So let's see, like, because now we have some open interval. So let's see how we can find a suitable lambda such that we can, from this lambda, we have a and b. And then from the a and b and lambda, we find the delta such that this this intersection is non-empty. So if we define, let's define this, like find two sets. So we have this intersection, and then we just translate by x sub 0. That's our A, set A, and we have B is just the intersection of E, right? So clearly A is a subset of this interval shifted by x sub 0, and B is a subset of this interval, right? So because why we're using this, because now for the interval we can estimate the measure, and then from problem 5 we know this mu, the measure, because it is basically a translation of E intersect I, right? This greater than lambda minus b over a. And then mu of b is the same of this, which is also greater than lambda minus b. Yeah, lambda is what we want to find, right? But let's see this. If we know that if so our, and then this a also we know, like this a is also a subset of E translated by x sub 0, and then b is also a subset of E, right? So we have two. So if both a and b are subset of this and also this, so if a and b A and B overlap is non-empty, then clearly this E plus x sub 0 and E is non-empty because there are two subset, right? And then work. So if A, so we just work on the opposite of this, negative of this, right? So now let's measure this, the measure of this two set. We also know that, okay, this is I, A and B. This is the interval I. If we shift by x sub 0, the minimum number, the minimum one of is like x sub 0 is the minimum one, which is minus delta, and you pick A, right? And this is B plus delta. So we know like I is contained in this interval, right? Because this is the minimum value of this shift, and then the maximum value. And then I itself is from A to B is clear there. So now what do we have? So if we measure this union of this I plus x sub 0 union I, this is at most B plus, because they both contain this interval, right? So the length of the interval is B minus A plus 2 delta. And now we have A and B, a subset. A is a subset of this, right? And then B is a subset of this. So if A and B intersect is empty, then this union is the sum of these two, and then which is greater than 2 lambda B minus A, right? So if A and B are, intersect are empty, then the union exists. So if we pick, so now if we pick, the goal is trying to find some suitable lambda, and then we can find a suitable delta, right? So if we pick delta greater than 0, such that we have this B minus A plus 2 delta is less than or equal to 2 lambda B minus A. If we have such delta, what does it mean? It means like A and B must overlap, right? Because if A and B are not overlapping, this set, this measure is the lower bound is 2 lambda times B minus A. But then the upper bound, because they both are subset of this I plus x0 open I. So the upper bound is the B minus A plus 2 delta, right? So if we make this upper bound less or equal than this lower bound, then this cannot be true, meaning like A and B are overlapped. And then we can work backwards. So this E plus x sub 0 intersect E is non-empty, right? So if we can find this delta, and then this just meaning like delta is less or equal than 2 lambda minus 1 divided by 2 times B minus A, right? So remember we want to first determine, we want to find a suitable lambda, and then this delta has to be greater than 0. So meaning like we can pick lambda which has to be greater than So 1/2, right? So if we pick lambda is 3/4, then delta, we can pick delta to be 1/4 of b minus a, right? So if we pick lambda equal to 3/4, we work backwards. Then we have find this I, which is a and b, right? The interval a to b, and we have this greater than lambda times this. Then from this a, b, and lambda, we define this delta to be 1/4 of b minus a. Then we can have this argument backwards. Then we prove this e plus x sub 0 intersects e is non-empty. And we're done, right?